So in this equation, we know that energy is equal to h times frequency. We're given the wavelength though. So we also know that our equation with wavelength, c is equal to wavelength times frequency. So what we're going to need to do is rearrange this equation. We need to know frequency, we don't know it, so we could use this equation to find frequency, or we could just say c divided by wavelength is equal to frequency. So then if we go back and plug in over here, we could say that energy is equal to h times c over wavelength. H is Planck's constant, 6.63 times 10 to the negative 34th, and that's joules per hertz. Since a hertz is a reciprocal second, you could also call that a joule second. And we know that the speed of light is 3 times 10 to the 8th meters per second. And we know our wavelength was 3.16 meters. So if you actually do the math, you'll punch in the numbers on your calculator, 6.63 exp or EE, negative 34th, multiplied by 3 EE to the 8th, and I get 1.99 times 10 to the negative 25th. Divide that by 3.16, and my final answer is 6.29 times 10 to the negative 26th. In terms of units, we notice that seconds cancels, meters cancel, and your unit that's left is just joules, which is the unit of energy. And that's all of problem 2. Now we're in problem 3. I'm evaluating ink to go. And in problem 3, we need to find the wavelength of a piece of matter. An electron is a piece of matter. So we'd have wavelength is equal to h divided by mass times velocity. Notice that this is not new, this is a velocity. All right, so we know h is 6.63 times 10 to the negative 34th, and that's joules per hertz. We also know the mass is 9.11 times 10 to the negative 31st kilograms. Did you notice that I changed it from negative 28 to negative 31, and that's because the mass needs to be in kilograms. You should know how to do that conversion, but just in case, 9.11 times 10 to the negative 28th grams, grams on the bottom, kilograms on the top, 1 kilogram is 1,000 grams. If you divide that, you get negative 31st. And then the velocity, 2 times 10 to the 8th meters per second. All right, doing that math, we get 6.63 times 10 to the negative 34th divided by 9.11 times 10 to the negative 31st divided by 2 times 10 to the 8th. So I get an answer of 3.64 times 10 to the negative 12th meters. That's a 12. And you may wonder, how do we get meters? So I'll show the units over here in red. So we have joules per hertz. A joule per hertz is really a joule second, and that's divided by kilogram meters per second. So what I just did was take this, all these units, but not this number. All right, so now that becomes joule seconds times seconds over kilogram meter, or a joule second squared over kilograms meters. A joule is a Newton meter. So that, I'm going to come around here so I don't run out of room. So I'd have a Newton meter, and the reason it's a Newton meter is because it's a unit of energy or unit of work. So it's Newton meters times seconds squared over kilogram meters. You notice that meters then cancel. So now I have Newton seconds squared over kilograms. But a Newton is, you remember from physics last year, a kilogram meter per second squared. Then that'll be multiplied by seconds squared. So I just put all this here. Remember, force is equal to mass times acceleration, mass, acceleration. And that's all over kilograms. So seconds squared cancels, kilograms cancel, and that's how we end up with meters.